So the first stop today is Vanessa is going to be reading us. So Vanessa is a PhD student. She's at the University of Guelph, and she's, as we discussed briefly yesterday, she is working on both a combination of paleoecological and dendrochronological approaches to understanding fire history in the landscape.
Alright, I'm just going to start off talking a little bit more about my project before we get into the actual coring. I'm actually going to use my field assistants as demonstrators today, so just a reminder, this is Courtney, and with the chest waders back there is Graham. They've geared up to go in and take a core for us just close to shore here today. So my project is the multi-proxy reconstruction of wildfire dynamics in the foothills, and exclusively in the Hinton Wood Products FMA. So this is my polecat lake, if you want to call it a lake. It's kind of a pond. It doesn't have a name, so I've named it PC1 because it's access off the polecat. Just to give you an idea of some of the bathymetry, it's about 1 meter deep across. Close to the edge is about 75 centimeters, but the deepest spot that we found was back in that far corner, and it's about 1.5 meters. Just under 1.5 meters, and that's where we actually took our Livingston piston core when we were here a few weeks ago. So my study encompasses not only the lake sediment, but also the tree rings. So I'm using a multi-proxy approach. The main objectives are to reconstruct the spatial and temporal variability of fires here. So we touched on this a lot yesterday, but looking for those mixed severity regimes and that spatial variability within stands, but also temporally, so going back a lot farther in time and seeing, I think someone touched up on that yesterday as well in a question, about the regime changing over time and that temporal aspect. So I'm hoping to go back about 1,000 years with my lake sediment, which should be accomplished. And then combining the two records to have a better understanding of that spatial and temporal variability. On top of that, I'm also going to be analyzing the controls on that variability, so what we call bottom-up and top-down. So our top-down control is climate in this area, and our bottom-up controls are things like elevation and aspect, slope, composition, density, all of those kind of local level landscape characteristics, which will impact that variability. You guys okay there? Okay. So those are my two main objectives, and they're rather large, obviously, and I have a really large data set to work with, but hopefully it'll all come together in the end. Just a little bit about my other study site that I want to talk about, because it's a little different from this one. It is located off of ZS Road, for anyone who's familiar with a lot of these logging roads. It's kind of up the Willow, Jack Wright, that direction northeast of here, about 75 kilometers from here, from town. And that's also a small lake, about 150 to 180 meters across, very similar to this. It's a little more difficult to get to, so I chose to do this one today. It's even more mucky walking up than this, if you can imagine. So why I chose these two study areas is something that I also wanted to mention. We did had some chats with Rick Bonner at Hinton Wood Products about areas where they suspected there might be mixed severity, areas of concern that they wanted us to do research in, and he kind of set me up along this transect, if you go from here directly out to my other lake. And also I used the Alberta vegetation inventory data to narrow it down to stands or areas that had stands that were more than 100 years old. Clearly in this area it's highly fragmented, those are difficult to come by. And last summer, Lori can attest to this, we hiked around and scouted out about 20 lakes in total, going to them looking for that ideal lake that Mike talked about yesterday, so nice and small and no major inputs or outputs from that lake. So we hiked through some good wet...
We had some knee-deep days.
Yeah.
We spent lots of hours up to our knees.
Yes, a lot.
Lake.
Yeah, so we finally decided on these two, and I've set up my dendro sampling around these two lakes, so it was really important to select the lakes first and to select ideal lakes. And so what I've done with my dendro sampling is set up 24 sites around each of my two lakes, so I have a total of 48 sites. And they're divided up into kind of the four cardinal directions, and I have 6 sites in each direction in order to capture that charcoal that are coming from those fires in the surrounding area into this lake. So again, I think Mike mentioned yesterday a 10-kilometer radius, or we discussed might have been ZEV. 95% of the charcoal comes from local fire events, comes from that 10-kilometer radius. What I've done here is gone a little bit smaller to 6 kilometers. So I put up my 6-kilometer radius around my lake, divided into my 4 cardinal directions, and then randomly selected from that Alberta Vegetation Inventory polygon data some polygons that were at least 100 years old, and also I took into consideration access to these sites. At each of those sites, I set up a sampling strategy similar to Raphael and Lori, your work in the Berland watershed as well, with the N tree design. So we sampled 20 trees, canopy and sub-canopy, around that plot center, so the 20 closest trees, I should say, and also did some hunting for fire-scarred trees and buried fire scars in some downed wood, and taking partial and full cross sections. As for my lake coring, which I think you guys are about to get started on, so we're just doing this next to shore today. One, it's just easier if anyone wants to give it a shot after they attempt to get one. We can just walk out and do it, but it should be somewhat representative here because the lake is about 1 meter deep across, hopefully. So what Courtney's doing right now is just seeing how deep the water is where they're going to be coring, so that they can take that length into consideration for how far to drop the core. What we want to get is what we call the sediment water interface, so that's just above the surface of where the sediment begins. We don't want to disrupt that upper sediment, so we just want to kind of capture, we're aiming for, I think you guys are aiming for 10 centimeters above. So they're aiming to get about 10 centimeters above that surface, and we're using the gravity core today, and this is not what we used when we cored our lakes. We used the Livingston piston core, which I do believe we're going to try out later at Little Trefoil Lake with Mike in Jasper. So the gravity core is more for the surface sediment, probably about 50 centimeters, if that, with this tube that we have on there. Don't fall again.
Going down. Back out.
Yeah. So just if you guys remember from the diagram that Mike had yesterday, how the gravity core works is they've actually held up this little stopper. Can you point to the stopper portion, Courtney? Right there. So right now it's above the core, and there's a little bit of an opening. And there's a weight on the string that Courtney's holding there, that she's going to drop, which will release the pin and drop that stopper once they get it into where they want the sediment to start. So going back to Mike's straw analogy yesterday, it'll kind of put the thumb over the straw, and then they will pull it up and put a stopper in the bottom so that they don't lose their sediment when we take it out of the water. And then we'll do some extruding.
You actually push it down?
So they've pre-measured how far that they need to go.
I think we need to go deeper than that. Okay, I think that's it.
In a normal application of this, it just sinks in under its own weight.
Yeah, okay.
And if the sediments are solid, you're going to need to slam that down with a little more force than that.
Good, like that. Great.
So in here, our sediment is really, really soft, so if you just let that go, it's probably just going to fall right through. Here, the whole thing, I think, would go right through the sediment because it's so soft, so we're trying to.
Got it?
You got a little bit? So it's a little mucky because obviously walking out there, we've disrupted the sediment around it. So ideally, we would do this off the side of a blow-up raft or a boat, which is what...
You normally do it, you go out a little further and then...
Yeah, we found the deepest spot in the lake, actually. And so what we were coring off of when we used the piston Livingston core this year, we created a coring platform. So we had 2 canoes with a metal frame that we put some plywood on top. We made our way out so you can actually stand and be really stable to actually core directly above where you're coring. And it worked really well. It was fun to check in all those pieces. But yeah, that's what we've used for the piston core. Yeah, kind of. So sometimes you might want to try this a couple times until you get a good sediment.
There's, some lights are popping up here.